Of course, all of this discussion about tail areas makes us think of p-values, so we're going to now see how we can use these normal distributions to find p-values. Remember, the notation we use for a normal distribution is n mu sigma. When we're talking about a p-value, we know that the distribution we look at is centered at the null parameter. So instead of mu here, we now say just center this at the null parameter, and that the standard deviation of the distribution we use is the standard error of our statistic. So the distribution that we're going to use is the normal distribution with mean equal to the null parameter and with standard deviation equal to the standard error. We'll look at a simple example here involving one proportion with null hypothesis that the proportion is equal to 0.8, a one-sided alternative hypothesis that the proportion is greater than 0.8, and some of these details about our sample here. So let's just sort out the details. First of all, our sample statistic is this one here, our p hat equals 0.88. We can see that that is consistent with our alternative hypothesis. It's greater than 0.8. Our null parameter is the value that is used in the null hypothesis, so that is 0.8. And our standard error is given explicitly as 0.045. Now our z-score formula of x minus mu over sigma becomes what we call the z-statistic now. Instead of x, we have our sample statistic. Instead of mu, we have our null parameter, and instead of sigma, we have the standard error. But it is the same formula that we used for z-score, and we now start to call it the z-statistic for this hypothesis test. Therefore, our z-statistic is, the sample statistic is 0.88, the null parameter is 0.8, and the standard error is 0.045. So this is the expression we're going to put into a calculator, or I can do a little bit of it first. This is like 0.80, so that numerator comes out to be 0.08 divided by 0.045, getting us 1.7 repeating, which I will round off to 1.78. All right, this is looking back at our alternative hypothesis again. This is a one-sided test, and it is in fact a right tail test because of the greater than. So this is a right tail out of these options. We'll need to know that when we go into the normal distribution and select a tail. Okay, so on this curve here, we're going to mark the center of the distribution at the null parameter. That is my 0.8. Now, almost 2 standard deviations to the right, but not quite, we have our sample statistic p hat equals 0.88. And what we used to know where to mark that is that we have a z-score of 1.78. So that 1.78 is really the value that I'm going to use in StatKey. I will shade this area. And then go into a normal distribution in StatKey and find the right tail, the area of the right tail to the right of 1.78. So here with the standard normal distribution, right tail, 1.78. Okay, and looks like we get a tail area of 0.038. And that tail area is our p-value. What we do from here is exactly what we did when we were finding p-values using randomization distributions. We would either compare this to a given significance level. For example, in this case, we would reject at alpha equals 0.05. Or we would describe the strength of our evidence using a scale. We would probably call this strong evidence because it is noticeably below 0.05. So this is strong evidence in favor of the alternative hypothesis. We will leave out the conclusion in context since this was really just a p-value exercise and there wasn't really a context that we started with here.